we'll go ahead and hop into. This is not a slide-heavy presentation. This is mostly demos, but I just wanted to give you an introduction to what we're doing. I'm doing this. I'm really doing it on my own just because I enjoy it, but I'm doing it in the context of Polaris Solutions, which is who I work for. You know, this is not a sales pitch. It's just we have to say that's who we are at the beginning of these things. So yeah, I told you. Okay, so a little bit about me. I'm a cloud architect there, mostly Azure. I have been doing this forever. I love technology. I always have, always will. It's just fascinating, and it's like it's getting to do new tricks and stuff every day. Even in those meetings where you're like, why am I talking to this project managers? Even then, there's still some magic to be had. Actually, probably not. Those meetings are terrible. But that said, Polaris is all about app modernization, and we're an Azure and Microsoft shop. So that's me. There's some more links at the end. But I wanted to go ahead and jump right into what are distributed applications. So for those of you who already know what this is, bear with me, but I wanted to make sure that nobody's left behind. In essence, when I say distributed application, I don't mean Kubernetes, I don't mean containers, I don't mean anything other than an application that has more than one node. So it could be you've got your web layer and your data layer, or you've got your message bus in the background, or whatever it is. Anything that has more than one moving piece is by nature distributed, especially if it goes across network boundaries. So don't worry if you don't know about Kubernetes or you don't know about Docker or any of that other stuff. Distributed application for the context of this discussion is something that has many moving parts that you can't just load up into one solution and debug everything all at once. That's kind of what we're talking about. So we already did this. So some of the benefits, I'm not going to go through this too much because I'm not trying to sell you on distributed apps, but you get things like you can scale individual pieces of it. You can reduce your latency by doing things that you can't really do in a monolithic app by, beefing up your message bus, or even having a message bus. You can have some reduced latency there. You get better fault tolerance. Loose coupling just lets you plug and play things a little easier, and you can do eventing in a way that's actually meaningful when you're doing a distributed application. But that comes at a cost, and you guys hit on basically every single one in the beginning there. You've got higher complexity, you've got security issues because you have more of an attack surface. You have to deal with deployments and your ops folks. You've got costing to have to deal with because it's more complicated to track those things. And trying to trace and debug and diagnose distributed apps becomes an exponentially worse task the more things you have in it. So those of you who've been in this space, you know this pain. So do the Microsoft guys. So like I said, Tye is a product made by the .NET folks. Anybody who knows their names, the main people are Glenn Congdon and David Fowler are the two main guys working on this, but they are in the heart of .NET, so they can do things that we can't do because they can get into the guts of it and change things. So their goal is essentially they started this last winter. Well, I guess it's 2 winters now ago, but in 2019, the end of 2019, they were sitting there and they were working on some microservice stuff themselves, and they were like, this sucks. Why does our tooling suck so much for having when people are dealing with microservices? Why does Visual Studio and VS Code, why are they so hard to deal with when it comes to having lots of microservices that are talking to each other and having to deal with external dependencies like Redis and SQL Server and Postgres and all that other stuff? They said we can do better. And so I think the story goes is those two guys I mentioned kind of they want their own two separate ways to try to solve the problem, and then came back and smashed the results together into Tye. And Tye had a lot of momentum for a while, and like I said, they had something come up recently that they had to deal with. So I just wanted to put this out there. This is actually as of 21 days ago. I put this out there today. I asked Glenn just to make sure that they weren't abandoning this thing, because in November they said this was actually going to be part of .NET 6. So that's still the plan. This is not a toy, and this is not a a dalliance from someone. This is actually addressing a problem that they know they have, and some form of this will be in .NET 6. So I mentioned that again just because don't be afraid to use it, because it's not going to go away. I mean, I guess I can't say that for sure, but the people that are making it are saying it's not going away. So that said, Tye doesn't address all the problems of distributed applications, but it addresses these three. And these are the ones that are the ones that make me the angriest as a developer. When I have to load up a whole bunch of stuff to get some crazy complicated distributed application to work, when I have to install 45,000 applications behind the scenes for my local environment to work correctly, when I have to understand other people's projects that I don't care about, the complexity there is unacceptable. And especially when you're debugging a problem that's occurring somewhere in the guts of a distributed system, that is difficult to say the least and very time consuming. Additionally, somebody touched on it earlier, deploying these things can be tricky. The more nodes you have to worry about, the more interconnections you have to worry about, the worse it becomes. And full disclosure, I am not a fan of Kubernetes. I'm a fan of what Kubernetes enables, but I think it's terribly complicated for what it does. But when you get into that space, deployments become even more complicated. And then diagnostics, when you have 50 services running locally, how do you know what's talking to what? How do you know where the things, unless you put a million debug statements in or a billion breakpoints, how do you know what's performing poorly? So those are the things that Tye attempts to address. So now we're going to switch into something more fun. We're going to actually look at some code. What I did was, because I felt like it and I hadn't dealt with it, I threw together, I started with the out of the box .NET 5 Blazor template that you can get whenever you want to start a new project. And the idea here was to go from, let's pretend that we're a little startup and we don't care about code quality and practices, and we just get stuff out the door and we build this monolith and it's great and everything's exciting, we're making money. And then all of a sudden bureaucracy comes in and other third parties come in and we have to start breaking apart some of our services into their own microservices. And then we make the mistake of tying those microservices together. And then we have a problem because we have all these different codependent services. We have to figure out how to maintain the connection strings, and we're in a distributed application space and we hate it. So then from that point forward, we start talking about how to use Tye to untangle that, how to bring in distributed tracing and logging, how to bring in things like SQL Server, how to speed up, how to do things like load balancing on your local box, how to bring in every kind of database that exists, and then a quick demo of how to actually use Tye to take your local development environment and essentially lift and shift it into Kubernetes, which is kind of cool. So with that said, before I get going, did I leave anyone in the dust in terms of any of the terms there? Or is anybody confused about anything? Any questions about where we're going to go, or any concerns? Or did I say something that's totally stupid? I don't have the chat up here.
The Blazor app you're doing, is that WASM or is that server side, and are you using an API with it?
The app it's a Blazor client server. It is WASM in the browser, but it uses a server side backend to do the communications to other microservice APIs. Did I say that right? I think I did. So it's got a client server pair, two projects, runs WASM on the front end, but all the calls made to the server essentially are just will be passed throughs to other microservices when we get there. So we'll look at the first project first, and you'll look at it, and if you've done the Blazor templates, you'll see it's just the starting point there. And I just used it because this isn't a talk about Blazor or any of the other stuff. It was just an interesting starting point for me.
Sure. I think the perspective I was going for had more to do with the authentication and authorization and how that might have interplay with the microservices.
Not in this talk. Good question,
Okay,
though. That's a good point, because it is part of how to make this work. But I'm actually going to ask at the end for suggestions on how to make this talk better or a follow-on talk. So I've already got that. I just actually jotted that one down because that's a great point. I was hoping no one would ask because, it's one of those difficult things, but I hear you and you're right. This we'll be talking about mostly how to deal with the dependencies and how to deal with tracing your apps and how to deal with not having to screw around with Docker and Helm and other stuff to get things onto your local box. So, and then I see someone was talking about Dapper. Some of the people that are working on Dapper, and this is not the database version of Dapper. This is something else for distributed applications. It's being made by the same folks who are making Tye. So those two projects know about each other, and Tye actually has, what do they call them? Recipes for Dapper. So that's actually a talk that my buddy, he wasn't able to do this month. So normally this talk is a combination of Dapper and Tye because they kind of go hand in hand. They're not the same thing, but they play well nice together. So that's a good call out because I totally forgot to mention that. So thank you for mentioning that. Okay, so let's see some code. Okay, so I'm just gonna run this. This is the first. Oh, actually, let me go back to this real quick. If you want to look at code as we go, all of this is out there in that link I just sent. Each layer is its own folder. So each layer is essentially builds on the previous solution. So if you want to go out there and look, each one, I missed one of them because I didn't have time to come back and fix it. Most of them have fairly fleshed out readmes. They go into more detail than I'm going to go here. My goal here is for you to be able to actually use this and not just have this thing in the background of your mind like, okay, there's this Tye thing, whatever. So there's a lot of detail out there to show you how to get from A to B for all the stuff we're going to talk about. There's not going to be time to do that in here, but if you are interested, that stuff is all there. So just to I can just show you real quick, just so you have an idea of what we're dealing with. There are 10 episodes, and each one builds on the previous one and gives a little flavor as to how we got from A to B. So I'm just gonna load up. We don't get to Tye until here. So I'm gonna kind of blast through these guys quickly because I just want to show for people who aren't used to the progression of how you go from monolith to microservices. I want to at least give a little bit of flavor of what can happen along the way. So I'm going to run this real quick. As you can see, we've got a client and server, a front end and a back end, and then just like a shared, class library that has entities in it. Like I said, for anyone who has seen the Blazor sample, this is it, right? It's the counter, and you can fetch some weather data. There's nothing here that isn't just out of the box. You can just create this with one line of a command line if you want to. But the point is I wanted to use it as a starting point because why not? So pretend we're this company and we've got this amazing website that has this wonderful weather experience that's just random data. And all of a sudden we have interest in people using the weather data outside of the application. So somebody has a bright idea to make this into a microservice. So that's the next step, which is right now we just have a controller here that just generates weather. So the next project I'm going to show you is just all we're doing is we're doing what the natural flow would be in most orgs, which is take that stuff that's part of the monolith, pull it out into its own web project and make it a microservice. So we're going to pull that up instead. And again, the code here doesn't really matter. The only things I want to show you is now we have a weather API. So we've got our microservice here. And we now have to do not use this as production code. This is just real quick garbage bootstrapping to show you kind of what will happen. Because if you go from nothing to microservices, you're probably going to see this kind of stuff in your code where people are put hard coding in URLs or whatever. And then you have to worry about, how do I manage this? This is the hard part about distributed applications, is right here. This and connection strings is, how do I manage as I grow this? How do I make sure that my connection strings and my ports for my local host don't clash with other microservices and all other stuff? So you're going to see as we grow this, you're going to see this is going to balloon, and we're going to get to a point where it's not maintainable. But the point here is that we've now moved the weather retrieval into a separate API that is retrieved across the network. So it is now distributed. It is no longer part of the monolith. And we need to make a web call. We need to maintain this thing. Normally, you'd put this in app settings, or you do something, which you wouldn't hard code that, but that's what this is. So I'm not going to run this because it's exactly the same app. It does exactly the same thing, but weather is now a microservice. So again, we're going to get to the interesting part in a minute, but we're doing a micro version of what a lot of companies do, which is start with a monolith, start breaking stuff apart, start making the mistakes that we're about to make, and then they need some way to unwind that, and that's what Tye can help do. So now we're going to hit number 3, which is now we've grown our company a little bit, and we need, for some reason, someone decided that we're now a company that can track people's to-dos. So now we, instead of just having weather, we have this new concept of person and a new concept of to-do. So I'm going to run the app real quick, but all it is just 3 more microservices, and they're really dumb. They don't do anything. It's all in memory. There's no database yet or anything like that, but we have the ability to add a person, and then we can see our people, and we can add a to-do, which has really nothing to it, and we can see our to-dos. That's all it does. But because we've already started down the microservice route, we want to keep going that way. So instead of packing that right into the front end, we've made them microservices. So what does that do? Well, we've tripled the number of these things we have to worry about, right? We now have 3 connection strings that we care about. So, you might say, not too big of a deal, but let's say you had 1,000 of these, that becomes a problem. And let's say 10 different development teams are dealing with all those different microservices. You need a way to make sure that locally, remember, we're talking local, when you need to run the front end, you don't want to have to care about how these APIs work. But right now, you kind of have to. You kind of have to know what their endpoints are. You got to make sure your local ports are open and all that other good stuff. So I'm going to kill this guy, and then I'm going to move to the last non-Tye thing to show you what 90% of the clients I've gone to that have done microservices have made this. I'm going to call it a mistake. It's not always a mistake, but it's an anti-pattern, which is let's say I don't know. Let's say the boss's son decided that we need to connect that people can't exist without to-dos anymore, and to-dos can't exist without weather anymore. They have to go together. So a person has to have to-dos, and to-dos have to have weather. So in our infinite lack of wisdom, we have decided that we will simply connect the person controller on our person API to the to-do client, which is to this guy, and we will connect the to-do guy to the weather API client. So that's bad. You're not really supposed to connect microservices unless you absolutely have to. You can do it, but then you come up with this dependency chain that's hard to manage. And the reason it's hard to manage is for all the reasons that you guys listed at the beginning, which is how do you know what talks to what, and how do you know what's slow, and how do you know what's breaking where, and how do you maintain all those connections between all the different nodes in your system? Because the worst case scenario is like a fully connected graph where you have every single microservice talking to every other microservice. And if you go back in time, there's a great presentation out there. I should have brought the link. Some guy was talking about how Dell painted themselves into that corner, and it was just impossible to maintain. So now what we have is we have the front end depends on person, which depends on to do, which depends on weather. The front end also depends on to do and on weather. So we already have 6, 7 places to have to manage these different connections. Now you could pretty easily have just in your app settings, just say, okay, person is going to talk to do, and to do is always going to be localhost 5,000 and whatever it was. And you can copy that across your app settings, and you're kind of good to go. But that's assuming that you have access to all of those app settings and that you really want to change all that stuff. Like, who wants to manage all those connection strings and all those ports and all that stuff? And then even if you can manage that, if you have a bug in let's say weather, if you are detecting it in server, you need to know how to run person to do and weather just to get to that bug. So that's where Tye comes in. That's the first third of Tye. So the first bit of Tye is to eliminate all that for you. It's to get rid of the notion of concrete hosts and ports and all that other stuff, and to use a bit of the magic of Docker without you having to know anything about Docker. So I'm going to show you what you're really here for, which is let's fix this with Tye. So yeah, Tye YAML. So let me pull this up. So if you want to use this, you will need to install .NET 5 and Tye. So if you come to the main README, this is how you get Tye. What Tye gives you is this command line. That's what it gives you. You will also need Docker in order to use most of anything that Tye does. So just bear in mind that if you want to do this, you at least have to have these 3 things done. You don't need .NET 5 if you're not. That's just for this demo, but you at least need these 2 things. So we're in a place now where we have all these applications running, and we want to kind of simplify that a little bit, and we want to know how they're talking to each other. Like, how do you know what's talking to what? Let's say you're a new developer and you have a brand new machine, and like, how do you figure that out? So what I'm going to show you is right now there's I renamed it. The very first thing you do is you come in here and you type Tye in it. Fancy command that all it does is it will run through and it will find all the projects that are underneath where you are, and it will create services for them. So that's really boring, right? Like, anybody in the world could write a piece of code that can go and find project files and put them in a file. What's important is if you run your project through Tye rather than just right through Visual Studio directly, it will create a Docker container for each one of your projects. It will create an ingress, which you don't need to know what that is, but basically it'll create a network for all of your things. And then if you ever want to refer to your person API, you simply say, give me API person, give me whatever it's connected to. And what it will do, which I'll show you right now, is that was not a question, was it? All right. Anyway, what it will do is you can see it actually packages these things up and runs them as Docker containers. Well, I'll show you in a minute because I need to refresh that. But what the most interesting thing it does is this guy right here. So this is really cool. If I go, every time you run Tye, you automatically get a dashboard that shows you everything that's running. It automatically generates fresh ports and HTTP and HTTPS endpoints for you. And it automatically will give you access to what you would normally see in your console window. So each of your dependent things is now in one pane of glass, and you can see, I've got my, everything that's running here. If I make a request, let's say I want to go to the server, I can go and hit my weather thing, and then I can go back here and I can look at weather, and theoretically I can see I've got live logs into that. You can also see, if you want to, you can see things like performance metrics automatically out of the box. Anything that's like a performance counter is here. So you can see what's going on with your memory, with your CPU, and all the other kind of good stuff. So just with 2 lines, one Tye init and Tye run, you get this sort of grouping of all sorts of stuff. And if I flip back to the code, what's interesting here is I have changed this to use something a little more dependency injectable. So now we're injecting our client that we care about for each one of these things. But what's interesting is when we set them up, now what we're doing now is instead of getting it out of our app settings, we're getting it from Tye. So if I go to this thing, this is part of the Tye configuration extensions. It's got get connection string and get service URI. All I have to do is say, give me whatever you've done, Tye, with your magic, give me API person. Give me the endpoint for it. I don't care where it is. If you deployed it to some other machine, if it's local, I don't care. Just give that to me and I'll use it. So you don't have to manage, you don't have to have port clashes and all other stuff going on here, because Tye handles all that for you. So that's the most basic, very, very basic use case of Tye. There's a lot more we're going to look at that's way cooler, but just this alone, it at least gives you the ability to group all of your things together and to see what's going on in terms of, your logs and your performance and these bindings. So any questions on that? Again, I know that's not super exciting, but it's the beginning of the excitement.
So this is helping us with our, traditional HTTP services. Is there anything built in around any kind of message queuing or anything that'll cover those communications that need to happen that aren't user facing?
Yes, and we'll get to that shortly. So that's actually, I don't know if it's the next one, but there's one in here that we're going to talk about that. So let's go on to the one that's a little more cool. I think this is cool in and of itself just because it's nice to be able to see everything all in one place and to not have to, like, every time you pull in a new service, you have to like, okay, I got to slide the local port by one and give the HTTP add one to that and all that other crap. It does all that for you. And you don't have to know anything about Docker to make this work. That's what's kind of cool is because a lot of people don't care. Like, developers shouldn't really care about Docker and Kubernetes, in my opinion. They're necessary evils and they're useful, but I don't really care about how to make a container when I'm just trying to add a call to my weather API. So it abstracts all that away from you. So let's pull up let's kill this, and I'm going to show you something that they're working on. So if I break, I'm not sure if it'll do it or not. No, it'll do it on the next one. So let's pull up the next guy, which is 6. Okay. So the next guy here, this one, when I saw this was like, oh yeah, I have to use this. Okay, so if you're used to working in a distributed environment, hopefully you have access to something like Splunk or Elastic or some other log aggregator that will let you see all the logs across all your different applications in your dev or your prod or your staging environment. But locally you're usually screwed on that. Locally, either you have to put your logs into the dev environment and then have some sort of filtering to get the information back out, or more likely you just don't have them. Similarly, if you want to visualize what's going on for complex call chains, you usually locally don't have access to the tooling to do that. But because Tye works in a Docker space, these out of the box, all I've done for this project is I've added Zipkin and Elastic. That's all I've done to that's the only difference between this and the previous one. What that's going to give us though is some really cool stuff. And I think showing it is more interesting than talking about it, because this directly addresses somebody's point about how to debug and trace distributed applications locally. Okay, so we got this thing running. We now have our dashboard now has Zipkin and Elasticsearch. So Zipkin is a distributed tracing tool. So if I run this query, some really cool stuff's going to happen, right? No, it's not, because Zipkin, the way it works and the way that Tye works is because Tye has smashed all of these things into one network for us. Zipkin can automatically be aware of what's going on in that space and can tell you about all the dependencies that are happening. So let me show you what that actually looks like. I'm going to pull up the front end again, and I'm just going to make a bunch of calls. I'm going to call weather, call people, get my to-dos. I'll add a person. I'll add a couple of these guys, and we'll see what it's doing. So we'll go back to people, go to weather again, we'll make some more calls. Okay, so we've done a bunch of stuff. Now when I run this thing, I could see all the stuff that just happened in my space. Now this in and of itself is kind of cool, but what's really cool is this. So you automatically get to see where things are fast and slow and what calls what with Zipkin. So I didn't do anything other than add Zipkin, but now I know if I was a brand new developer and came in, I could immediately see that the front end server talks to person, which talks to to-do. I can immediately see that. And I can immediately also see, if I want to, I can see it as a picture. And I can see the calls that are being made between the different nodes in the system. Now we only got 4 nodes in this system, but imagine if you had 100. This would be pretty useful to have. 1, because it'll tell you what's going on live, and 2, because human beings are terrible at maintaining documentation. I hate doing it, and every time I add a dependency, I'm not going to remember to go update my, whatever the tracking mechanism I have in the organization. This right here will give you, if you run your application, it will automatically build for you your dependency chain and show you what it is. What's even cooler is that this is happening locally. This didn't require me to have something installed out in a server somewhere. This is just here. It's just here. So the other side of that, so that's for sort of your distributed tracing and dependencies. The other side is the Elastic Stack, which if you've used it, this will be old hat for you. But just by adding that one line, I can now search my data from all of my. It's aggregated the logs from every single app. So if I want to see, and it does it in a way that any environment would do it. It actually does it in a way where if you look for your person call, you're going to see a to-do call next, and you're going to see a weather call next. It'll show you timings. It'll show you if there are errors, they would be in here. It'll show you all that stuff. And normally, like if you're running Splunk or even Elastic, normally you don't have that locally. In fact, you almost never have that locally because it's a big pain in the butt to get set up. So these two things make figuring out where your performance issues are, where your dependencies are, what's going on in the application way, way, way easier, because you don't have to deal with the white noise of other developers in your log space, or you don't have to deal with not having a log aggregator, or you don't have to deal with having to go to the database for your logs. It's just here. So these two things by themselves are huge time savers.
Yeah, those are awesome.
I think, you know, I would have loved to have had the time to stamp out one that had like a 50 chain dependency, but I just didn't. And again, this here actually, if you look at it, this here should show you when you're doing like a review, you have a problem here, really. I mean, I use these negative terms. It's not necessarily a problem, but you have a potential issue because you really probably shouldn't have this happening. Your person microservice probably should just be calling its own version of the bounded context of the to-do API so that you don't make a chain call like this, because you don't like if you had let's say you had a circular dependency, you could actually see that on here, but having this here is a potential to have a circular dependency. So it shows you those kinds of things. And again, I think, like I said, I think this one's really cool too, because it's just being able to see what's going on and who's calling what and what the timings are and all that kind of good stuff. I think it's fantastic, and you just don't usually have that locally. And again, I'm going to hop back to the code. This is all I did. I literally did nothing but do this. That's out of the box functionality, because the Tye team understands that these two features, whether or not you use Zipkin or something else, these two things are huge pain points when you do your inner loop development for distributed applications. So I anticipate these things growing and becoming more powerful over time, but even as they are, it gives you insight into how the application is working locally that it's really hard to get any other way. So any questions on that before I get to the next thing?
Yeah, are those things that you would run in production? Sometimes you would run like the Splunk and whatnot and logging, of course, but
right.
Is Zipkin something that's only for local, or is that? I'm wondering about the performance impact, I guess.
Zipkin is something that you would have in production, but you wouldn't always run it in production. It's more like a diagnostics tool that you would have at the ready if you have a problem. It doesn't really incur much of a performance impact in and of itself, simply because it's this thing that's just kind of sniffing the network within your Kubernetes cluster, it's basically your Kubernetes cluster. Elastic would definitely be something that you run in production, because that's the freeware version of Splunk. We'll get to it at the end. Currently, Tye does not support deploying these things, the external dependencies. It only deploys services, but we'll talk about that in a minute. But yeah, Zipkin is a tool that I recommend having installed in every environment, and I usually just leave it on because I haven't ever seen a performance hit, but it's a good question. I mean, it's good. It's worth investigating. So, and then the other thing, in case anybody cares, these logs actually, because sometimes you might want to search them like with maybe like a text search rather than just the tool itself. They actually do exist locally. Just by giving it a log path, you can, this is the Kibana export here. So if you need it, you have access to all of the different stuff. All right, so what we've seen so far is we've seen a journey from a company that had a monolith to a company that started spaghettifying their microservices, and they've had trouble along the way how to maintain and deal with those locally and how to trace them. So we now know how to trace, we know how to handle the connection strings between services, But now let's talk about external dependencies. So these are technically external dependencies, but they're kind of special citizens because they're extensions. Tye also has the ability to automatically download and run Docker images without you having to know anything about Docker. So that's what these two are, but you can actually specify your Docker image with what kind of looks like a baby version of a Docker YAML file. So I'm going to show you that next. So let me kill, where is it? Let me kill this guy. And we'll go to the next guy. Come on. Okay, yeah, here, this is the thing I wanted to show you. So this is a known bug that they're addressing right now. So if you see this when you've killed a Tye run, it's because you have your dashboard running. The dashboard runs on SignalR, which is actually one of David Fowler's babies. He's one of the Tye people. There's a bug, there's a race condition where the dashboard will keep the network alive in the Docker cluster. So that's why you get that error. It doesn't do anything bad. It just takes longer than it should to kill the network. So like I said, that's an open issue on the Tye thing. So if you run this thing later or you're playing with this and you get this, don't worry about it. It just means that you had the dashboard running when you killed your Tye instance. All right, so let's head into SQL. We're gonna add SQL Server here. So I hate databases because they make my life difficult. I don't enjoy them. They're a necessary evil. But what I really don't enjoy is coming onto a new project or getting a new machine and having to install SQL Server and having to run all the scripts to get a database up and running and all that other stuff. So what I wanted to show is how to get out of that, how to not have to deal with that, how to pretend that SQL Server doesn't even exist. So in our world now, I liberally stole this university domain from another Microsoft sample. So all of this stuff is from another Microsoft GitHub repo out there. The link's in the README. What I wanted to do is this was already built to use SQL Server. I just saw a question here. Is this related to any work Microsoft GitHub is doing with code spaces? Not that I'm aware of. I don't think so. And I don't think I can adequately compare Tye with Zookeeper on the fly. So I can't answer that question, Alex. I'm sorry. So what we have here is, this is what we've added to our Tye YAML. We've added SQL Server, and we've added this guy. We've added a new service, and we've added a new container. Now like I said, I don't really care about containers and Kubernetes and Docker and all that stuff. I mean, I do, but most people don't, because it's not something that you should care about if you're just dealing with the code. So the goal here is to go from I don't have SQL Server to I have SQL Server running with the database I need installed, with the database seeded with initial clean data, and I don't want to know anything about the connection string or anything else. I just want it to work, and I don't care, and go away. That's the goal here. So you'll see that we have specified this is just for local again. You would never do this out in the real world for like an actual deployment. But I have, for my local purposes, I said, I would like you to download the latest version of SQL Server 2019. I would like you to run it on port 21433 externally, because I want to be able to connect to it with my SQL Server Management Studio sometimes. And I also want to make sure that the end user license agreement is automatically accepted when the container runs, and that I have a super user SQL administrator password set up so that I can log in. That's what this does. So as long as you have Docker installed, which if you've gotten to this point in the demos, you will have had to have installed Docker. If you run this, it will automatically download this if you don't have it, or it will just use it if you do. It will create a new image. It will bind in these variables into your connection string. And just like these guys, if you ask Tye to give you the connection string for the Usador SQL Server, it will just give it to you. It doesn't matter where it's running. If this port wasn't static, it wouldn't matter. It would still give you the right port. I just made this static because I wanted to be able to connect to it to show you so I don't have to look it up to show you that you connect it with SQL with SSMS. So I'm going to run this real quick so you can see what we did. It's really not exciting in the front end, but what's exciting is what is happening on the back end. Oh, actually, sorry, I can't run it that way. That's not the way I wanted to run it. Just kidding. Actually, I could run it that way, but I'm choosing not to because I want to show you how to do it from here. So what you're going to see here is the same old stuff that we normally do, but you can see right here, if I didn't have that Docker image installed, it would automatically get that for me. And I'm going to really quickly while that runs, it doesn't take very long, but I'm going to, for people who don't know, if you go out to Docker Hub, just go here, pretty much anything that you care about that is like a third-party thing is likely to be here. So like if you didn't know that SQL Server was all that stuff that I had put in the Tye YAML, you can come here and you can find it. And this is where you find what you need to do. This is exactly where you go to find, okay, I need to set this variable and this variable. I might need to set this, and it'll tell you, where was it? The name of it. This is what you put in for, you just get rid of the Docker pull. You just copy that, and that's exactly what's in the Tye YAML. So there's nothing magic there. This is essentially, for the uninitiated, this is the, NPM or NuGet of containers, or one of the major ones. So anyway, that said, we should have this thing up and running now, and now we have a SQL Server. So whoop-de-doo, yay, we have a SQL Server, but we actually have a real SQL Server now. Like I have on my local host a SQL Server instance that has the database that I want in it, and I didn't have that before. So to drive home that point, I'm going to kill this real quick. And once this is done, if I refresh this, it won't exist anymore. There will not be it doesn't like install it on your computer. It spools up a container and puts it into the ingress in Docker so that you can actually run it. But once you kill Tye, it's gone. Like it's completely erased. You don't have to worry about anything else. And there's that stupid error again. But now this isn't here anymore. There is no such, this database doesn't exist anymore. And so you can go from nothing to a fully created SQL Server instance with your databases using, again, using SQL migrations. So this is, we're not going to talk too much about SQL migrations, but if you don't know what they are, this is how you get from nothing to something using .NET code. So this will create the tables, it'll create the database, it will insert seeded data if it's not already there, and you're good to go. So this timed out and it's not there anymore. So again, I'll just run it again, and just to prove that that actually worked, that it wasn't any sort of trick or anything. But that's a big deal. Like and if you do want it to persist between runs, you can certainly do that as well, and that's in here. So if you need, for example, if you want your data or your schema or anything else to persist between Tye runs, which you probably will, like you don't want to lose your stored procedures or whatever else you're doing between runs, you can have the data persist, but the instance still goes away. So like if I uncomment this, all it means is that we want to persist the SQL data to a volume that lives across any number of instantiations of the SQL Server image. So anyway, the point is that we've got this database, we've got the tables, they're seeded with what we want. They've got all the data we care about. So you can get to a clean known state every single time you run your application forever, as long as you maintain your data migrations, which you need to anyway. You can have this just out of the box for free forever. So that to me is pretty powerful, because I don't like to have to search for data. I don't like to have to reproduce data situations. So as you find bugs, you can add them to your seeding code, and you can maintain for every single developer a clean, isolated place where they can play with whatever data they need. And they don't have to know anything about Docker. They don't have to know anything about Kubernetes. They don't have to know anything about anything other than just they need to get this project, because the YAML file is part of the solution. So that's I think that's hugely valuable. So any questions on what I just did? Because that was a little bit that's the second third of what Tye does. So the first slice is this stuff up here, find my services and hook them up for me. The second slice is I need containers. So this kind of crosses that boundary because these are technically containers, but they're special because they're first-class citizens. But this is more like I need a custom container. I need SQL Server. So go get it for me, download it, throw it into Docker, create a container for me, bind it up to whatever you need to do, and give me the connection string. That's what this one is for. So, and then the last third we'll talk about shortly, which is deployment. So I know I stomped on my question. So any questions?
No, I mean, I think that's really good. I mean, obviously your connection strings and that you can use environment variables and things, I'm assuming.
Thank you. I forgot. Yes, you're right. I forgot to show you that. Here, this is how you get it. So this is how you get your connection string. It's very similar to what you'd normally do. And I wanted to show this too because when you go into Tye, they don't want you to be stuck in Tye. So if just by using a pattern like this, or if you were to just call your connection string in your app setting the same thing as what you call your service in the Tye YAML, you can fall back because this will give you null. If you ask for it through Tye and Tye isn't running, it'll give you null. So you can always fall back to the app settings version, which is kind of what this does. So if I can't find it in Tye, I can just get it normally. Similarly, you can do something similar for the HTTP endpoints. So there's nothing in what we're doing that requires you to, once you drink the Tye Kool-Aid, to stay there. You can always get back out simply by going to your normal app setting space. All it is it just makes the gluing and the configuration easier for you, and it gives you all those kind of fancy tracing and other features. But you can always get back out simply by just doing what you would normally do, because ultimately within the code space, there are only two methods it gives you: get connection string and get something service URI. So those will return null if you're not running Tye, and you just fall back to your app settings. So the last little bits are kind of, well, we'll take a diversion here. Where is 8? So I don't care. One of the things that I've been burned on a lot in distributed application development is load balancing bugs. So just for a quick description, that's a bug where you've got 5 instances of your API running, and somehow they're accessing like a shared resource, or there's something going on between them that you can't reproduce unless there's multiple instances running. That is a fairly common bug, and it's really hard to debug unless you're in a real environment, because you don't have load balancing locally. You don't. But with Tye, all you have to do is add that in. So adding that one line in gives me 3 instances of my university service that are running behind a Dockerized load balancer, basically an ingress. So when I ask for API University, I'm going to get an external URL that behind the scenes is fronting 3 instances of my API University. And when you start debugging things, you will actually have 3 instances of API University running, just like you would in a real environment. You need to have 3 instances running to load balance. So you can, by adding this, by doing 300 or whatever you need, you can create a load balance environment that you can debug in locally simply by doing this. So one of the things that the example goes through in the README that I'm not going to go through here is, because I'm replicating the university API, and the university API has SQL bootstrapping code in it to both migrate and seed the database. If I were to run all those at the same time, they're going to stomp all over each other, right? Like I'm not going to be able to do migration simultaneously. It's going to cause a problem. And I can't do seeding simultaneously, or I might get duplicate data. So one of the issues that the README goes through is, how do you fix that? And you'll notice that another thing that I added here was Redis. So Redis is, again, it's just another image. It's another container image. And Redis is a distributed cache. For anyone who hasn't used it, just think of it as memory that anybody can use. So any number of machines in your environment can hit the same memory using Redis. That allows you to do things like distributed caching, but it also allows you to do things like distributed locking. So the reason this is here is that I want to be able to lock the database across 3 instances of the university. So again, it's not really part of Tye, but what I'm illustrating is if you're in here and you're doing your startup code and you're doing your registration or your migrations and or your seeding, if this code wasn't here, and it wasn't to start with, it will break because you're going to have 3 instances trying to do that all at the same time. So in order to fix it, I had to use Redis to do, that's one of the ways to do it, to do a distributed lock. So I could say, okay, all the people participating in this world, I want to lock you on this key and only allow 1 instance at a time to go through here to do migrations. That is nothing to do with Tye, but without having something that allows me to run replicas, the only way for me to test this would be for me either to spool up several versions of Visual Studio and run different instances and somehow get them to launch at exactly the same time so that this bug would occur, or I can just tell Tye, give me replicas, and I can get my load balancing scenario right here where this will die without having a distributed lock. So again, the point of this isn't to understand anything about Redis. The point of it is that this is a bug that is only really testable and fixable in the context of load balancing. And in order to do that, you either have to deploy this thing out to your dev, or you have to figure out some hacky way to do it locally. Instead, you can do it with Tye and just blast as many replicas as you want. This is borrowed from the Kubernetes concept of replicas as well. So that's kind of what this is. So any questions on that? I know that was sort of a more not exact. I wasn't really showing any running application there, but I just wanted. Actually, I should do that. Let me do that. Is this the right one? No. So while that goes, does anybody have any questions on what I just went through? Is anybody confused? Am I
No,
way off base here?
I think it makes sense. I can't help but thinking that you wouldn't need the Redis if you weren't doing the migrations, which you shouldn't probably be doing in production anyway. But
No, but it's a
but it's a
contrived
good
example
example.
that
Yeah.
exactly. Yes, as I alluded to before, do not take the code for the most part in here as, I mean, some of it's all right, but it's not meant to represent real world scenarios. It's meant to represent as real world as we can get without having to, have tons and tons of code to get to the point where we
Sure.
can have these things.
Yep.
So I'll just
on that thought too, it just kind of, it's like a little itch or something. Newing up the HTTP client in a microservice architecture is driving me crazy. You got to inject that and use a factory to avoid resource exhaustion.
which one are we talking about?
Any of your services.
Like calling them?
Yeah, you've got HTTP client being newed up in individual controller action methods or something.
Yeah, I think once I got to Tye, I switched it to this to do DI. I didn't want to introduce DI to start with, but you're right. In the first 3 or 4 examples, it's it's exactly what you said. It's just newing up garbage and not fixing anything. So once you get to the Tye, it becomes a little cleaner with DI and everything like that.
Perfect.
So yeah, the only real interesting thing here is we've got this over here now. By default, you just get 1, but now we have 3, and they're hidden behind a common endpoint. So if I hit this, I'm going to hit round robin. I'm going to hit whichever replica, whichever instance I'm on. And you can see that here also, where you can see I've got an instance that's ends with 06 and an instance that ends in 5 and an instance that ends in C, and they all are there and available to do things. And nobody blew up because we had things running at the same time. So that's really all I wanted to show you there is you can replicate stuff. So
no, that's cool. I had a bug today I was working on where it became necessary to log the machine name that was processing transactions, and it kind of happens here and there, but where you could have just by knowing which instance is processing something, you might have a problem with one, although I don't think that would happen with just replicas.
Right. And I think, it's probably not something you would normally use, but in those cases where you need to do a distributed debug like that with multiple instances, it's really nice to have it in your toolbox. The other thing that is useful in this space is, I have Redis now, right? But I don't have anything that can do Redis, can show me Redis. But you can, if you just download in your Tye file, you can download the thing that will let you manipulate your Redis instance. So that's a common theme you're going to see in the next two examples is once you get into the container space and don't have to actually worry about containers because Tye does it for you, the sky's the limit, because now I have all of a sudden I can do, again, completely in isolation. As soon as I kill Tye, all this stuff and all the resources go away. I'm not like overloading my development machine with all this garbage that I only care about when I'm running the app. So again, we get that through, like I just said, okay, I also want this tool that allows you to explore Redis. And similarly speaking, I mean, there's no container for SSMS, but for the next example, when we talk about other databases, there are other web-based interfaces that can manage Postgres and MySQL. And you can bring those along for the ride, and you don't have to worry about anything. It's just done for you. So that's just that's kind of the theme here, is that if you don't want to know about Docker and containers and Kubernetes and any of that stuff, you can still use them with Tye without knowing anything other than sort of the very, very basics of what you need to copy paste from Docker Hub to come into here. So it's a very nice, gentle abstraction away from the harsh reality that is Docker and Kubernetes, because those are by themselves on their own are kind of high-end topics that take a long time to understand. So let me wrap this thing up quickly here. I'm going to hit just because I think I built this one because I feel like no one had I couldn't find one out there that had an example of something that showed you how to connect to sort of the major players in the database space. So this is a beefed up example that has SQL Server, Postgres, MySQL, Maria, and Mongo all running as their own as data stores for each of these new crappy APIs we've got here. Each one of these has exactly the same flavor as we just went through for SQL Server. It will download the image for you. It will give you the connection string. You need to give it you got to copy paste your environment variables to get it up and running, and you get an instance of MySQL running on 23.306 externally, and you get an instance of Maria running on 23.307, and you get Postgres on whatever the port is, and you just get those things. And then also, I bring in Adminer because that allows you to this is not Adminer. I bring in Adminer because I want to be able to see MySQL and Maria and Postgres without having to install some crap to do it. So that's what this is for. And then I bring in Mongo, and I bring in Mongo Express so I can see the Mongo data. And again, we have Redis and all other stuff. So this grows, and this isn't super simple anymore. But this file gives you the ability to run 5 different databases plus the admin interfaces for them plus Redis with just by running Tye run. That's a pretty big deal, because in order to do this manually with Docker and get all that stuff done yourself or with Kubernetes, it would take a long time to get it done, especially if you're not familiar with it. You'd spend probably weeks trying to figure out how to do this. So I can run it, I guess, if you guys want to see it, but it's not any different than the SQL Server. It's just more stuff. And in the interest of time, I think I probably, unless you guys want to see it, I think I'll just skip to the last thing, which is deployments.
Just a question. Yeah, demos are demos, so I can agree with you, but on running it. But how much overhead, if any, is there from Tye? And sorry if I missed if you said that earlier. Are we picking up much more over what it would just take to natively run the containers, or should we?
There is no overhead from Tye, because all Tye does is it builds, depending on what you're doing, if you're doing deployments or you're running it locally, it simply builds the Docker infrastructure for you. So it's running and it's sitting there in the background. I suppose there would be, the slight overhead would be from the dashboard, because there is a SignalR process running. So there is a little bit of a hit there, but your app code, the things that are actually you care about, those are running. There's no impact. Tye, they're completely unaware of Tye and vice versa in terms of any performance, anything like that. Because cool. Tye is, as far as I understand it, and I am by no means an expert in Tye. I don't think anybody is except for the .NET guys, because it's just, there's this documentation sparse and it's kind of like if you're fumbling around. But my basic understanding is it it really is an abstraction away from having to do the Docker stuff yourself. You're still running Docker, you're still running Kubernetes, but you're not running it in a way that you have to pull your hair out trying to figure out Helm files and all that other stuff. Okay, so the last thing, the thing that the Tye folks themselves say that no one uses, so bear that in mind as we do this, is deploying to a Kubernetes cluster. So the goal is, the Tye folks, their goal was simplify inner loop development, so simplify your local life, make sure that you can debug and trace and all the other stuff, make sure you can get containers and all the other stuff. And then the last thing is they want your local development and your real deployment to be identical. So the idea there would be you can go from your Tye YAML from your local environment to production without doing anything other than just running Tye deploy instead of Tye run. That's their goal. They are not there yet though. But they are definitely not at that point. There are some features here that are really neat that allow you to get stuff up in the cloud, up into a Kubernetes cluster or a local cluster easily. But this will not take you from like the one we just looked at with all the SQL servers and all other stuff. It will not do all that for you. All it will do is it will deploy your code. And there are a lot of good reasons for that. You don't necessarily want a developer to be able to push a new version of a SQL server out to your Kubernetes cluster, but it would be nice to have that capability. So with that said, let me pull this guy up real quick. The code, so like I said, you can't deploy databases and things like that. So I've revert the 10th version, the 10th in the series here, kind of goes back to one of the earlier ones where we just have the in-memory stuff and we don't have databases or Redis or any other stuff because Tye can't deploy that. It can set up secrets and it can do all that stuff for you, but it can't actually deploy any of your external dependencies. So real briefly, for people who have not done Kubernetes, especially AKS, this might be totally unfamiliar space. But in a nutshell, I created a Kubernetes, an AKS cluster out here just for this demo. And this should be empty now, I think. Yeah, so there's nothing in here right now there's none of the APIs, there's none of the front end stuff, there's none of the ingress, there's none of the, there's nothing for my app here. And what's neat about this is that, we'll see if this, I may have to run my credentialing stuff. Actually, I'll just do that. Let me show you. If you want to get to this point, make sure that you do read this one in particular. You will need to read all of the README here, because particularly you need to do this stuff because you need to get your container name, you need to get your credentials, you need to get your token, you need to get all that stuff ready to go. Because this one's gonna deploy out to AKS, so I have to get all that stuff here. So I'm gonna go ahead and copy this thing and blast it into the console. It's gonna pull up a browser for me to log in. Whoop-de-doo. So I'm logged in. It's gonna go grab my subscriptions. It's gonna go find the container registry that I want called Likens Tech, and it's going to get credentials for the resource group and that instance and this instance right here. So that's really what all that did. The README goes through all that stuff. I'm not gonna waste your time talking about it here, but that's all that does. So now when I run Tye deploy, and I run it interactively, it's going to do all the stuff that everyone hates to do, which is everything that's kubectl, everything that's essentially running Kubernetes commands. It does all that for you. I don't know why it's red. I looked at the code. This is what they decided to be the informational log color, which kind of blew my mind to start with, because I'm like, why am I airing out all the time? But don't worry if you see red in this space, because it's not the end of the world. Right here, you see it does know that I have external dependencies. So it is asking me to specify an endpoint from external dependencies because it doesn't know what it is. So for now, I'm just going to put in a dummy. Oops. I'm going to put in a dummy URL, and I'm going to do it for Elastic too, because it doesn't really matter here. But you can see it does actually create secrets out there for you. So when you deploy this thing, if you don't have your secrets, secrets are the Kubernetes speak for sensitive strings. I'll just show you real quick. So it created my Zipkin secret and my Elastic secret. Similarly speaking, if you had a SQL Server or Postgres in there, it would ask you for the connection string because you should have that out in your Kubernetes clusters already, but it will create secrets for you. So it will at least do that, but that's all it does for external dependencies. So anyway, it does some stuff and it pushes out, it creates your Docker images, it pushes them out to when it can. Note again, it will not push external dependencies, which made me sad, but it just won't do it. So it's only going to push my front end and my back end and all that other stuff. This shouldn't take too much longer, but as this goes, we should have back here, we should start to see, we've actually got deployments and pods for our, again, I'm throwing terminology around that if you don't know Kubernetes, you're not going to know what this means, but ultimately, you don't have to know what Kubernetes is to get your stuff out there. So I have both a deployment and a container, a pod for each of these things. Client shouldn't be out here. I didn't mean to deploy that. I need to fix that because client doesn't belong out in Kubernetes, but just ignore that for now. Pretend that didn't happen. But what's important is now that this is done, the big, well, I guess it's still waiting, but the big sort of payoff here is if you go to your services and you say, okay, I've got a public IP. I now have my app running in Kubernetes out in the cloud, and I can hit it. I haven't given any domain stuff, but I can actually hit the public IP and actually do, all the things I could do locally. So that's the payoff there, is that if you develop in Tye, if you use Tye for your local configuration, you can get to Kubernetes without doing anything else. So that's not really possible with any other tooling in the .NET space right this second. Not that easily. So that's pretty much it. I'm gonna hop back here, make sure I didn't forget anything, and then we can talk questions and stuff like that. So yeah. Oh, I guess I forgot something there. So with Tye, we get service discovery. So it will automatically find any services you have. It will automatically download and create Docker images and Docker containers for you. It'll automatically give you your ports and connection strings. With the Tye dashboard, you get some basic monitoring. And if you just add in Zipkin and Elastic, you get distributed tracing and distributed log aggregation. You can have clean databases right out of the box if you want them, just by downloading the containers and doing migrations and things like that. And if you want to go that far, you have local load balancing as well as easy AKS deployment of your code. So it's really a pretty crazy powerful tool for as small as it is. And they're adding features periodically. And like I said, it is going to be part of the .NET 6 release. Some version of this will be built in. So with that said, the obligatory slide, I'll leave this up for about 30 seconds. This is what Polaris does. If you're interested in talking with people like me, we can certainly make that happen. We love to do this kind of stuff. I know that you guys are not interested in being sold to, but this is our mandatory slide here. And then finally, actually I'll do this slide. There is one question I want to ask, which is what can we do better in this presentation? But before we do that, questions, comments, concerns, thoughts, because we're basically at the end here. Anything I glossed over or can explain better, I'm happy to try. Again, I'm no Tye expert, but this is as far as I've been able to take the tool so far.
Maybe just additional resources or things that you found useful as you were trying to figure this out outside of the GitHub repo, and maybe a video or two on YouTube.
Okay, good call.
I've got a couple links here. I could post them in the chat window.
Yep.
So obviously it's pretty new, so I don't know a lot of people doing this. So there's probably not a lot. It's not like exactly, maybe there's a Pluralsight course, probably not though.
I'd be surprised, maybe though. Yeah, this is in version 0.6 something right now. So this is definitely still alpha, but it is very much usable. I have used this in client installs because it solves. Nobody has used the Kubernetes, the deployment portion, And I professionally, I think Kubernetes is probably going to fade away into the background and be the enabling technology that lets us do things like, Azure and AWS. They use Kubernetes and Docker to do all the magic stuff that we get to do on top of it. So I'm imagining that'll probably slowly fade into more of a, we just don't care about that stuff. But there are people using Tye today to do the local stuff because it is, it changes the game. When you have a complex application, it's hard to go back once you've used it. I didn't show it because I didn't want to bounce between tools, but the .NET folks are very, very pro VS Code. So they have written, and I don't think they've released it, but they have written a Tye extension for VS Code that does a lot of this stuff so you can stay in your IDE rather than having to bounce back and forth between PowerShell or another command line. I don't know why they haven't released it yet, because the last demo I saw at the .NET stand-up looked pretty solid. But anyway, if you're partial to VS Code, that support is imminent. So yeah. All right.
I think that was a great session. Thank you very much.
Let me, if people still have this open, I'll flip the slide to the next one. I'm not gonna leave this up because it's really for me, but if you have any comments and you're still in there and you want to let me know something that sucked or something that could use more information, like, I think it's a great idea to have additional resources. I don't know why that's like so obvious. I don't know why I didn't do it, but it's a good call out. And I'm happy to talk with anyone either on GitHub or through email or anything about any of this stuff. And if anybody actually uses this, either in ways that we talked about here or in different ways, I'd love to hear about it, because this is one of those things that it's kind of like a hidden gem in the .NET world that, it's just not being pushed very hard. But I think it's super, super cool. So it'd be neat to see if anybody actually does anything cool with this.
There's a question in the chat. I think it's around using Tye on Mac.
Which, am I blind?
I can read that out for you. It says, can Tye run on a Mac?
Tye probably cannot run on a Mac. I bet you it can only run on Windows right now. I bet you they haven't ported it elsewhere. But you can install it through, I don't know. I mean, you can install it through PowerShell, so that's not going to help. Yeah, I would bet it can't.
It did mention in the FAQs on the Tye GitHub thing, there's a link to it a couple above on the FAQs, that you can run it on any mainstream OS.
Oh, well, there you go then.
That's awesome.
Playing without the database. Yeah, that's Alex. That's my question too. Like, deploying without the external dependencies is one side of the spectrum would say you don't want to deploy things like a database or Redis as part of your normal deployment process, because you're going to want people in that space kind of who are good at configuring those tools in your Kubernetes environment. But on the other side, it's nice to be able to say, I want to ship this app to somebody. Like, I want a client to just be able to do it. Like, how do you do that? Do you have to ship them Helm files and all that other stuff? So I think there's a very strong argument to be made that maybe it's not defaulted to deploying those things, but it should definitely be an option. But it's something that I've asked them to address, and they haven't come back with an answer yet, other than they're aware that it's a shortcoming, but because so few people use the deployment side of Tye, they haven't prioritized it. My thought is that probably people aren't using the deployment side because you can't do that, like, it's kind of a chicken and egg thing. Any other questions?
Do you know if Tye works well with one of the DevOps tools? Have you tried that, or do you know if somebody has tried that, like maybe Azure DevOps, Jenkins, or anything like that?
You mean as part of your CI/CD pipeline?
Right.
Yeah. If you go to the Tye site, they have some admittedly sparse documentation on how to integrate it with your pipelines. So yes, you can. That it's very much, at least last time I looked, it was geared towards Azure DevOps, but I mean, I'm sure it will out of the box support GitHub, at least, since Microsoft owns them. And you know, I would assume and hope that the .NET 6 full release experience of this will be quite a bit more polished than what we're looking at here. Again, keep in mind, this is a very much an alpha tool. So when .NET 6 drops later this year, I think it should be a whole lot more polished and first-class citizen.
Did you touch on debugging? I think you mentioned it, but are you able to just reach in and debug those microservices?
Yeah, they run as, so if you're doing it in VS, this is why I hope that they drop the VS Code extension, because it's easier to do it there. If you're running in Visual Studio, they run as, you can do like, you can do Tye run debug, and I think you can do something like star. And that will run the containers to the point where they're just about to launch, and then it will wait for you to attach a debugger to it. Like in Visual Studio, you can do it just with attaching, which admittedly is not the slickest of experiences. During some of the talks or the discussions the .NET folks have, they would like it to be in here. Like Tye will be in Visual Studio. It'll be like run with Tye, so you don't have to do the debug attach. Right now, you either have to attach to your running process, or like I said, the VS Code extension, which I can't show you because I don't have it, allows you to do it from all within VS Code. So yes, you can debug. In here, it's a little crappy because you have to attach. Not the end of the world, but it's definitely not as easy as a one button run. And then VS Code will be later on. So that's it. Thanks for being patient. I know that was a lot. I really do think it's, I wouldn't have made this talk if I didn't think it was a cool tool that had some legs. So I would say don't be afraid to play with this thing. You might not do anything other than maybe make your first step of your local development life a little easier, but anything you can do to make your life easier is good, right? So I recommend going out there and just playing around with it.